Let's look at how we can convert grams to atoms. So if you look at our mole map here, you see grams, but you can't go right to particles. Particles are atoms or molecules. You've got to go first to moles and then to particles. So we'll use this map to help us as we convert from grams to atoms. Let's start with an example, then do some practice. So say we're given 471.3 grams of gold. This is just a number made up for the problem. We want to convert that to atoms. To do that, we're going to start with grams. We've been given grams here, so grams, we divide by the molar mass, or if we just have an atom, the atomic mass. Divide by that, we get our moles. Once we have moles, we can multiply by Avogadro's number, and that'll get us up here to particles. Particles are atoms or molecules, anything like that. So start with 471.3 grams, and we're dividing by the molar mass, or in this case, the atomic mass. We get that from the periodic table. For gold, that's 196.97. I'm going to round that, and I'll round my numbers in this video just to make it a little bit easier. Do what your teacher wants you to do in terms of number of places after the decimal point. So we divide this by our atomic mass, and the units for atomic mass or molar mass are grams per mole, because that way, when we divide, grams cancel out. We're going to be left with moles. That's what we're looking for right now. We need to get to moles. So we have 2.4 moles of gold. So now we have our moles. We can multiply by Avogadro's number. That'll give us atoms. So we multiply our moles here by Avogadro's number, and that's atoms in moles. 6.02 times 10 to the 23rd atoms in 1 mole. Moles, they cancel out. That leaves us with atoms. And our final answer, 14.4 times 10 to the 23rd atoms of gold, and that's in our 471.3 grams. So there's a lot of steps, but the key is you go from grams, you divide by the molar mass or the atomic mass, you get moles, then you multiply by Avogadro's number, and that gives you particles. In this case, we're talking about atoms. So now you give it a try. Convert 62.3 grams of calcium to atoms. Remember, you've got your map here, and here from the periodic table, we have the atomic mass of calcium. So we start with our grams, we divide by the atomic mass of calcium. So we're going from grams to moles. We divide by the atomic mass, in this case, of calcium. Then we take our moles here, and we're going to multiply by Avogadro's number, and that gets us to atoms or particles. Note that grams canceled out here. That left us with our moles, and then moles canceled out here, and that left us with atoms. But what if you have something like a molecule? Say H2O. Let's try that. So we've got 23.2 grams of H2O. We want to find atoms. So it's the same process. We go from grams, divide by the molar mass to get moles, then we multiply by Avogadro's number to get particles. In this case, we're looking for atoms. There is a little bit more of a step, though, in here when we have molecules. So let's try it. We have our 23.2 grams that we were given for the problem. We divide by the molar mass of water. The molar mass of water is 18.0 grams per mole. Need help finding that? There's a link at the end of this video. So when we divide, grams will cancel out. That's going to leave us with our moles. And we end up with 1.29 moles of water, H2O. Now we can multiply by Avogadro's number, and that'll give us the number of water molecules. Let's try that. So we have moles. Right here, we want to get to the number of molecules. We need to get molecules before we get atoms. So we're going to multiply by Avogadro's number. That'll give us the molecules, like this. And there are 6.02 times 10 to the 23rd molecules in 1 mole. We multiply, mole's going to cancel out. That leaves us with molecules, and we get 7.77 times 10 to the 23rd water molecules. But we want to find the number of atoms in 23.2 grams of water. So here's how we do that. 1 water molecule has 2 plus 1, 3 atoms. So we could set it up like this. Since each water molecule has 3 atoms, basically we just multiply this by 3. Here's how the units work out though. We multiply our molecules of water, and there are 3 atoms in 1 molecule. Molecules, that unit cancels out, we're left with atoms. So we end up with 23.31 times 10 to the 23rd atoms. So if you had 23.2 grams of water, this is how many atoms you would have. But that counts the hydrogen and the oxygen. If you just wanted to have the hydrogen, how many hydrogen atoms, you'd multiply by 2. If you just wanted to know how many oxygen atoms you had, you just multiply by 1, which would give you this same number here. Now you try one. Convert 37.6 grams of CH4, that's methane, to atoms. Give it a try. So we take the number we're given for grams, we divide by the molar mass of CH4, that's the methane here. If you need help, there's a link at the end of the video for that. We get 2.33 moles. You take moles, because we're here at moles now, we're going to multiply by Avogadro's number, and moles cancel out, we're left with molecules. So we have 14.0 times 10 to the 23rd molecules. Once we have our molecules, then we know that 1 molecule of CH4 has 1 plus 4, 5 atoms. So we multiply 5 atoms for 1 molecule, molecules cancel out, and we have 70.0 times 10 to the 23rd atoms in 37.6 grams of methane. You could change this to 7.00 times 10 to the 24th if you wanted to do that. If you wanted to know how many carbon atoms, you would just multiply by 1. If you wanted to know how many hydrogen atoms, you would multiply by 4. So that's it. It's a lot of work. There's a lot of steps, but just remember, grams to moles, then you get to particles. Once you're at particles, you can figure out how many atoms you have. This is Dr. B. Thanks for watching.